Hello everyone, Mr. Hein here to talk about how to do function machines today if you need help with this. Before I start, let's make sure we get our head in this space. That way we can bring all our focus here and help us understand it. So say our part in your chair, be aware of your thoughts, whatever is on your brain right now, and then focus on the breath. Breathe in and out through the mouth. Just like that, in and out. And last time through the nose only. If your brain has wandered, that's okay, but bring it back to the breath. In and out. How do you feel? Hopefully you feel refreshed, your brain's a little bit more focused, you kind of forget where you were at, and that's a good thing. If not, keep at it. Trust me, it takes time. It takes years. I don't even know if I'm good at it. So here's how to do function machines and what they're saying. So I have 3 examples I'm going to work through here. Please pause the video as many times as you need to walk through it. So up at the top up here, this is called the input. We're inputting into this picture here, which this is we'll call it I'm not going to use the word. And then you have something coming out, which is the output. And this first one, it's saying your input is 5. And usually input is x. So we're going to say x equals. So over here, we're going to put 5 into where x is. And you could work in the box, but just due to space, I'm going to work out here. So this was the function. This whole thing is called the function. And we're going to talk about what a function means later, I think next week. And we're going to put 5 where x is. So we're going to have y equals 3, but remember from last video, use parentheses, 5 plus 1. And when numbers are touching, that's multiplication. So that means 3 times 5, which is 15, plus 1, which is 16. So if I put 5 into this function, what's my output? My output is y equals 16. And there's the first one. All right, so you're just putting 5 into where x is the input. Now, a slight variation that you might see on the work is like number 2 here, where -3 is my input, so that's like x equals -3. And now notice this function, it has something called f of x equals x to the third. And this is very important. All right, f of x, yeah, it's like the same thing as y right here, but it's more powerful because this f means that we're referring to a function where this is actually the function that we're calling f. So when I said function up here, that's technically not correct. Just this is really the function, truthfully. But if you're lost in it, it's okay. But focus on this right here. So f of x equals x to the third. This is the function f. And this is your input. So it's saying you're inputting x's into this function f. But what do we want? What do we want x to be? X wants to be -3. So you're saying, what's the function when I input -3? That's really what this picture is saying in math language. So that is this picture. What is the function when you input -3? So you got to plug it in for x. Remember, use parentheses. And that's to the third power. Now, what does powers mean again? That's how many times you're multiplying this. So you have f of -3 equals, which you just bring that down because you're saying, I want to find the output of the function f when I input -3, and this is what's happening. So you have -3 times another -3 times another -3, because there's 3 of them. That's what powers mean. Right? So we work through this. Well, let's see what it is. A negative times a negative is a positive. So if I just focus on these two, a negative times a negative is a positive, and 3 times 3 is 9. So you're going to get positive 9 times -3. We write it again. What's positive 9 times -3? Or positive times a negative is a negative. They're not the same, it's a negative. And 9 times 3 is 27. And there's your final answer in perfect form, where you would say f of -3, when I plug -3 into f, the function, which is this, my output is -27. And that's what that's saying in just a few letters and numbers. Right? Math can say a lot without actually having to write much. Right? The input of f when you plug in -3, so if -3 is your input for f, your output's -27. And then the last one, it reverses the process. is what's your input, right? We don't know what it is, but your output is 10. So it's saying what's x, what input x, when you plug it into f, gets you 10. Well, what is f? F is you're taking your input and you're adding 1. So what can you add 1 to? So in all of this process, we're going to add 1. What can you add 1 to get to 10? Well, that's pretty easy. I think you know it. That would be 9. So you'd say x equals 9. And I believe that's right. And you can check that, right? Does f of 9 equal, equal 9 plus 1? If you plug 9 in to x, do you get 10? Well, notice f of 9 would be 10, which is your output. Good. And if there's another method, this is another method. A little bit more complex, but maybe your brain thinks this way. Say you didn't know it was 9 or it was a harder problem. What you're really asking yourself is f of x, you're saying, I'm going to try that again. What input x gets me 10? And you're solving that equation. So if you want to get x by itself, how to get rid of a positive one, opposite of positive would be subtract. If you do it to one side, you have to do it to the other side of the equal sign. 1 minus 1 goes to 0, so you get x is equal to 9. And that's just another way we got the answer. A little bit more complex. That's why it's another method, not mandatory. It's just maybe your brain thinks that way. Good luck with this assignment. I hope these 3 example problems help you. Email me or come to office hours if you need any additional help or have any specific questions. Good luck.